Hello and welcome to my walkthrough for the 2024 GCSE Maths Predicted Paper 2. Now this particular video is for the higher tier paper, so if you are doing the foundation tier, don't worry because I have already done a video for that. So please check out my channel for that video. Now I've put the link to the questions in the video description. So what I would recommend you do is click on that link and go through all of the questions yourself first. And then when you finish the paper, come back to this video and then we can go through the answers together. So this particular paper I have taken from a website called MathGenie. So I just want to say a big thank you to MathGenie for providing the paper. And what they've done is they've looked at which topics haven't yet appeared from paper 1 and they've put those topics into these paper 2 and paper 3 predicted papers. So a few things to mention just before we get started is that I have got a playlist dedicated to past papers. So I always think the best way of revising is by just doing past papers over and over. So if you want to have a bit more practice with past papers, then click on the link that I've put in the video description and that will take you straight to the playlist and you've got loads of past papers to choose from. So another few things to mention is you can see that I've got chapter headings in this video. So if you want to look at a particular question, then you can just skip straight to that question to go through the answers. You can also see I've got my scientific calculator on the left hand side. So as I'm going through the paper, I'm going to try and talk you through exactly what I'm doing on here. And you'll be able to see what I'm typing into the calculator, which I think will be quite useful. And then just the last thing to mention, I will also be doing paper 3. Now there's quite a quick turnaround between papers 2 and paper 3. But as soon as paper 3 comes out, for the predicted paper, I'll try and create a walkthrough for that paper as well. It might be quite late, but hopefully I'll be able to do that just in time. Okay, I think I've rambled on enough. I think that's everything covered. So if you do have any questions, please post them in the comment section. I'll try to respond quickly. But without further ado, let's get cracking straight on to question number 1. So question number 1, the height of a building is 310 meters. Correct to the nearest meter. Complete the error interval for the height of the building. Okay, so our building is 310 meters. Now we're measuring to the nearest meter. So our upper and lower bounds are going to be half a meter above and below. Half a meter. So we always take half of whichever value they've given us. So 310 subtract half, well that's going to be 309.5, and 310 plus a half is going to be 310.5. So this is our error interval. Question 2, work out all of this business and give your answer in standard form. So we're going to get straight on with the calculator with this one. So if we open up our brackets and put 3.12 times 10 to the power of, which is this button here next to our squared button, and then our power is -6. So we've got -6, and then we don't just close our bracket like that. Obviously we have to come down, so we have to press the right arrow key, come down, and then close our bracket. So this is inside our brackets, and then we're going to divide by open brackets 2.5 times 10 to the power of, and we've got -4. Come down and close our brackets, press equals, and you can see it automatically gives you your answer as a fraction. If we press the SD button, we get a decimal, which is what we want. So let's write that down, 0.01248, but I'm not going to write that in my answer line because we need to give our answer in standard form. So our base number is going to be 1.248 because it always has to be between 1 and 10. And then we're going to multiply by 10. So let's think about where our decimal point is. If our decimal point is between the 1 and the 2, which is here, to get to this number, well, we're going to move our decimal point to the left 2 times. So we're essentially dividing by 10 twice, or we're multiplying by 10 to the -2 power. So that is our answer, 1.248 times 10 to the power -2. Question 3. 3 buses, A, B and C, all use the same bus stop. Bus A runs every 10 minutes, bus B runs every 12 minutes, and bus C runs every 14 minutes. All 3 buses are at the bus stop at 11 a.m. What time will all 3 buses be at the bus stop again? So for this question, we will need to work out the lowest common multiple of 10, 12 and 14. So the lowest common multiple of 10, 12 and 14. And the reason for that is because we want to know when they next meet at the bus stop. So that will be the lowest common multiple. So to do this, I'm not going to list out all of the multiples of each number and then look at when they meet each other. I'm going to use prime factorization. So let's break each number down into the product of its prime factors. So 10 we can say is equal to 2 times 5. 12, that's equal to 2 times 6, but 6 we can break down into 2 times 3. And then finally 14 is the same as 2 multiplied by 7. So now notice now we've broken the numbers down into the products of their primes. Now we can calculate the lowest common multiple. So the lowest common multiple, it needs to be a multiple of all of these numbers. So to be a multiple of 10, it needs to have a 2 times 5. So that's 10 done. To be a multiple of 12, it has to have 2 times 2 times 3, where we've already got one of the 2's. So we've already got one of the 2's here. So we need to multiply on another 2 times 3 by times 2 times 3. So that's that one done. And then to be a multiple of 14, it has to have a 2 times 7. And you can see we've already got a 2. We've got 2 of them, in fact. But we haven't got a 7 yet. So we need to multiply on a 7. So that's that one done. So what is this? So let's just type this into our calculator. 2 times 5 times 2 times 3 times 7. And we get 420. So the lowest common multiple of these 3 numbers is 420. And notice that is in minutes. So that is in minutes. So they're at the bus stop at 11 a.m. And then the next time they're at the bus stop together is 420 minutes later. Well, 420 minutes is exactly the same as 7 hours. Okay, because there's 60 minutes in an hour. 420 divided by 60. So let's just write that down. If we're dividing by 60, we get 7 hours. So we just need to add on 7 hours, and that takes us to 18 hours, which is the same as 6 p.m. So let's just write that, 1800 hours is the same as 6 p.m. So they next meet at the bus stop at 6 p.m. Question 4. The table gives information about the times taken in seconds by 20 students to run a race. So you can see there were 2 people who took between 20 and 25 seconds. 10 people took between 25 and 30 seconds, and so on. We need to work out an estimate for the mean time. Okay, now the reason why we can't work out the actual mean is because we don't know the individual times. All we know are the intervals. So we can only work out an estimate, and the best estimate is if we choose the midpoint. Okay, so we don't know how fast these 2 people ran. We know they ran between 20 and 25 seconds. So the best estimate is to use the midpoint. So my first column is going to be the midpoint. So the midpoint of each of these categories, we've got 22.5 seconds. Between 25 and 30, that's 27.5. Between 30 and 35 is 32.5. And between 35 and 45, well, that's 40. So just be careful, because notice these 3 intervals are the same width, but this last one is different. So don't just assume they're all going to be the same. Okay, now let's think about how long each of these categories took. So these 2 people, we're assuming they took 22.5 seconds each to run the race. So the total time they took, well, we just multiply the frequency by the midpoint. So 22.5 times 2, well, that gives us 45 seconds. And I'm going to do the same for each interval. 10 times 27.5 is 275. 5 times 32.5, let's put that into the calculator. 5 times, not 33, 32.5. That gives us 162.5 seconds. And then finally, 3 times 40 is 120 seconds. So we know how long it took for each of these intervals. Now let's work out the total time taken for everyone. So we just need to add up all of the numbers. So we've got 162.5 plus 45, not 44. I think there's something wrong with my calculator. Plus 45 plus 275 plus 120. 120. Maybe I'm not pressing the buttons hard enough. And we get 602.5. So that's in seconds. So the mean, how we calculate the mean is we do the total time divided by the number of people. Total time divided by the number of people. So the total time for everyone was 602.5. There were 20 people, and if you didn't know there were 20, it does say, but if we weren't told, we can just sum this column, that would be 20. So I'm just going to divide my answer by 20, and what do we get? We get 30.125, and that is in seconds. So that's my answer, 30.125. It doesn't say what to round to, so I'm just going to leave it like this. And I always do a dummy check with these type of questions. So does this answer seem correct? Well, to me it does, because if you think about the upper and the lower bounds, the upper bound is 45. That was the maximum time someone could have taken. And the lower bound was 20 seconds. So we know our mean has to lie between 20 and 45, and it does, and it's somewhere in the middle, so I'm quite confident that that would be the correct answer. Question number 5. ABCD is a trapezium, and AB is parallel to DC, which we can see here. We need to find the size of angle BCD. So BCD is this angle here. Now, at the moment, we've only been given expressions for the angles. So we're going to have to use some of these expressions to work out the actual values. So what I can see is these two angles here. So let me highlight those two angles. So this angle here and this angle. Well, I know there's a special relationship between these angles. These are co-interior angles. So co-interior angles. And there's something special about these. So hopefully you know your angle properties on parallel lines. Well, co-interior angles, they sum to 180 degrees. So you've got alternate angles which are equal. You've got corresponding angles that are equal. And co-interior angles always sum to 180 degrees. So we can write an expression for these two angles and then write that as an equation which is equal to 180. So we can say that 2x plus 19 plus 3x minus 6. So when we add these two angles together, well, that is equal to 180. So now we can just solve this equation. 2x plus 3x is 5x. And then we've got plus 19 minus 6. Well, that's plus 13. And that is equal to 180 degrees. And now if we subtract 13 from both sides, we get 5x is equal to 167. Therefore, x is equal to 167 divided by 5. 167 divided by 5. Apologies, that's the train going past. And that gives us 33.4. 33.4. So now we've found our value for x, we can substitute that into our expressions. Now we don't need to do it for all of them. I'm going to choose to only do it for a 1. So the one I'm going to substitute this into will be this one here. And the reason I'm choosing that one is because these two angles, so this angle here and this angle here, are also co-interior angles. And this is the one we want to try and work out, so we can do exactly the same thing with these two angles. So if I substitute this value for x into this expression, that gives me 4 times 33.4 minus 57. So what does that give us? So we've got 33.4 times by 4 minus 57. And if I convert that to a decimal, I get 76.6, and that is in degrees. So that is this angle. And finally, to find out what angle BCD is, so angle BCD, it's exactly the same situation over here. So we can just subtract this value from 180 degrees. So 180 minus 76.6. So I'm just going to do 180 minus previous answer. And that gives me 103.4 degrees. So that is my answer. Let's write it down here. 103.4. And again, that looks about right. It looks just more than 90 degrees. So I'm quite happy that that is the correct answer. Question number 6, part A. Complete the table of values for y equals 7 plus 2x minus x squared. Okay, so what we've got is, I'm going to write out the equation again. So we've got y is equal to 7 plus 2 times x. So I'm going to start off where x equals -2. So I'm going to put it like this. So I've got my value for x in brackets. And then we're going to subtract x squared. So again, we've got -2 squared. Now at this point, it's really important to note that this needs to be in brackets. Okay, you need to put your value for x in brackets before you square it. If you don't, you'll get a different answer because it will do the squared first and then take the negative of that. So make sure you use brackets for this. So I'm going to put this into a calculator. So we've got 7 plus 2 and then in brackets times -2, close brackets, and then subtract, and then we open our brackets again, put -2 in, not -1, -2, close brackets, and we're squaring that. Press equals, and we get -1 for our answer. So we get -1. Now, all I need to do is go back into my calculator. Don't delete anything. Go back into my calculator, and then just wherever it says -2, just delete that and put -1. Okay, very simple to do. And then just press equals, and you can see it gives us our value for when x is equal to -1, which is 4. So again, just all I need to do is go in, delete -1, put 0, delete that, put 0, press equals, and it gives me my value for y. So if you did want to skip along while I do this, then I won't be offended. That's absolutely fine with me. So when x equals 1, y is equal to 8. Now when x is equal to 2, and this does take a bit of time, but on your it's definitely the best way to do it, I think. It means you're not going to make any mistakes. So that's 7. And now let's delete 2 and put 3 in. And we get 4. And finally, when x equals 4, we get -1. Okay, so that is my table of values. So again, just to reiterate, make sure you put your negative values in brackets. Okay, now we have to draw the grid. So let's just read that question. So on the grid, draw the graph of y equals 7 plus 2x minus x squared for values of x from -2 to 4, which is what we've got. That's useful. So let's start off with when x equals -2, y is equal to -1, which is going to be there. And then we've got -1, 4, which is there. 0, 7, which is there. 1, 8, which is there. 2, 7, which is there. 3, 4, which is there. And 4, -1, which is there. And I'm actually pretty happy that this is correct because you can see it's nice and symmetrical. So now we just have to connect the points with a curve. So try to be as accurate as possible because usually you will have to use your graph. So I will try to do this as best as I can, but doing it on a tablet is a bit trickier. And obviously you've got a pencil. You should be using a pencil, so you can always rub it out if it's not perfect. So that's my attempt. Okay, it's not perfect, but I'm quite happy with that. So now let's take a look at part C. Yes, we do need to use the graph. So use the graph to find estimates of the solutions of the equation, this equation here. So our equation, notice, is exactly the same as this equation, but we've just replaced the y with 0. So that means all we're doing is, on our graph, we're looking at where does y equal 0? Well, y equals 0 along our x-axis. So along our x-axis here, that's not a very good drawing, but hopefully you get the idea. Anywhere our graph crosses this x-axis is our solution. So it looks like it happens in 2 places. So there and there. So again, these are only estimates. So with your answer, you will get some margin for error. So I'm going to say our solutions are going to be x is equal to -1.9. Oh, not 1.9, -1.9. Or, I think I'm just going to say 3.9 for that one, 3.9. And I don't know what the error is for this, but it's usually about 0.2. So if you've got something around these values, then you've probably got the right answer. Question number 7. Josh drove 39 miles from Luton to Cambridge. He then drove 63 miles from Cambridge to Norwich. Josh's average speed from Luton to Cambridge was 32 miles per hour, and Josh took 80 minutes to drive from Cambridge to Norwich. Work out Josh's average speed for his total drive from Luton to Norwich. So let's just remind ourselves how we calculate average speed. So average speed, well, it's going to be the total distance, and then we're going to divide that by the total time taken. So the total time. Now, we have been told the total distance, or well, we can easily work it out because we know that he travelled 39 miles from Luton to Cambridge and then 63 miles from Cambridge to Norwich. So the total distance here, well, that's just going to be 39 plus 63, which is equal to 102. So it's 102, and that is in miles. So that is the total distance. Now, the total time is a bit trickier to work out. We know, looking at this line here, we know the time it took to travel from Cambridge to Norwich, but we don't know the time from Luton to Cambridge. So let's work that out. So from Luton to Cambridge, what we're doing is we're working out the time taken. So if we just rearrange this formula to work out the time, we know time is distance divided by speed. So it's going to be distance divided by speed. So this is all from Luton to Cambridge. So the distance from Luton to Cambridge divided by the speed from Luton to Cambridge. So we know the distance from Luton to Cambridge is 39 miles. And then the speed, I think that is here. So the speed from Luton to Cambridge is 32 miles per hour. So let's put that into a calculator. 39 divided by 32. And we get 1.21875. So that is in hours, because it's miles divided by miles per hour. So that is in hours. So we know the time from Luton to Cambridge. So now we know both times. So total time is going to be the time from Luton to Cambridge, which is 1.21875 hours, plus the time from Cambridge to Norwich, which is 18 minutes. But I'm not going to put 18 minutes in here because we've got hours and minutes. So let's just convert 80 minutes into hours. So 80 minutes. Well, what is that in hours? Well, to go from minutes to hours, we need to divide by 60. So let's just put that into a calculator. 80 divided by 60. We get 4 over 3, which is 1.3 recurring. 1.3 recurring hours. So that's what we're going to add on. We're going to add on 1.3 recurring. So what does that give us? So I've already got 1.3 in the calculator. So if I plus 1.21875, press SD, we get 2.552083 recurring. And I'm going to write down everything. So that is our total time, and that is in hours. So now we have our total time. We can put that into our formula here because we already know the total distance. So let's just do this in red to make it clear. So let's bring this down here. So our total distance is 102 miles, and divided by our total time, which is 2.552083 recurring hours. Bit long-winded, but I'm going to keep it like this for now. So I've already got that saved, so I can just do 102 divided by previous answer. And I think now I'm going to round it because this is going to be our final answer. So we've got 39.97. Let's round it to 2 decimal places. 37.97, and that's going to be in miles per hour. Miles per hour, but we don't need We don't need miles per hour because it already says it in the answer line. So I'm just going to leave it like that. 39.97. And it doesn't say, again, what to round to. So if you have rounded that up to one decimal place, you could say 40.0. Or, you could have rounded it to 3 decimal places. Either way, you would get 4 marks if you got the correct answer. Question 8. Millie invests £2,000 in a savings account for 4 years. She gets 3.9% per year compound interest. Work out how much money Millie will have in her savings account at the end of 4 years. Give your answer correct to the nearest pound. Okay, so we're starting off, or Millie is starting off with £2,000 in her savings account. And the interest she's getting is 3.9%. So let's think about what the decimal multiplier will be. Well, that is going to be 1.039. That represents a 3.9% increase. Now, we're doing that for 4 years. So I could write this out 4 times, or I could just raise that to the power 4. So let's put this into the calculator. We've got 2,000 multiplied by 1.039 to the power of 4. Press equals, and we get an answer here of £2,330.73. And that is the amount of money that we're looking for. So it says work out how much money Millie will have in her savings account at the end of 4 years. So if it said work out the interest, we would need to subtract this value from our current value in the account to work out the interest. But we're looking for the total amount in her account. So this is how much is in her account, which is what we're looking for. But we need to give our answer to the nearest pound. So that's going to be £2,331 because we're going to round up. Question number 9. Work out the size of angle BAC. BAC, so that's this angle. Give your answer correct to 3 significant figures. So we've been given a right angle triangle and some side lengths, and we need to calculate an angle. So straight away, I'm thinking SOHCAHTOA. SOHCAHTOA. So the angle we're trying to work out is this angle. Now, from this angle's perspective, we've been given the opposite, and we've also been given the adjacent. So which trig function involves the opposite and the adjacent? Well, it's the tan function. It's this one over here. So let's write out what the tan function is. So the tan of our angle is equal to the opposite over the adjacent. So the tan of our angle is equal to 7.5 divided by the adjacent, which is 12.1. So that will be the tan of our angle, but we just want to work out what our angle is. So we need to take the inverse tan. So it's going to be inverse tan of 7.5 divided by 12.1. So let's pop that into the calculator. So we need to press shift tan. That will give us inverse tan. And then we've got 7.5 and then over 12.1, or not 11.1, 12.1. I keep making these silly mistakes. And then close brackets, press equals, and we've got our answer. So that is 31. 3 significant figures. We're going to round the 7 up to an 8. So 30.1.8 degrees. 31.8. And again, let's do a dummy check. That looks about right. So it's definitely on the lower end of kind of what you would expect. So 45 degrees would sort of be down here. It's a bit less than that, so I'm quite happy with that answer. Question number 10. The diagram shows triangle ABC. ADB is a straight line. The size of angle BCD to the size of angle ACD is 2 to 3. Work out the size of angle ADC. So let's just look at this first point here. Angle BCD, so that's this angle, to the size of angle ACD, so that is this angle. So the ratio is 2 to 3. So let's just write that down. So let's color coordinate it. So this angle, the ratio of that angle to that angle is 2 to 3. So you can think about it being 5 parts in total. So this is 2/5 of this whole angle, and this is 3/5 of this whole angle. So what do we need to calculate? We need to calculate the size of angle ADC, so that's that angle there. So the first thing I'm going to do is I can see this big triangle. We've been given two angles, so we can work out this angle over here just by knowing the fact that angles in a triangle sum to 180 degrees. So we can do 180 minus 83, which is this angle, minus 52. So what does that give us? 180 minus 83, oh, not times 83, minus 83, minus 52, and we get 45 degrees. 45 degrees. So this angle, this big angle is 45 degrees, but we know what each of these angles are because we know the ratios. So this will be 2/5 of 45 degrees, and this will be 3/5 of 45 degrees. So we could do 45 divided by 5 because there's 5 parts, and that gives us 9 degrees. So this angle will be 2 times 9, and this angle will be 3 times 9. So 2 times 9 is 18, and 3 times 9 is 27. So I think this one is the more important one because I can see that now we know this angle and we know this angle, we can calculate our missing angle. So angle ADC is going to be 180 degrees minus 52 minus 27. So let's put that into the calculator. 180 minus 52 minus 27, and we get 101 degrees. So that is our answer, 101 degrees. Question 11. A company has 9 employees available to complete a job. It is known that 7 employees can complete the job in 12 days. Davina says that 9 employees will be able to complete the job in less than 10 days. Is Davina correct? You must show all your working. So we know that 7 employees, well, they can complete the job in 12 days. And we want to work out how long it takes 9 employees. 9 employees. Okay, so first of all, the way I like to do these questions is I like to work out how long it takes 1 employee. So I always break it down into 1 first. 1 employee. So if 7 employees takes 12 days, well, 1 employee is going to take them 7 times as long. So we need to multiply by 7. And 12 times 7 is 84. So it will take 84 days for that 1 employee to complete the job. So now we can work out how long it will take 9 employees. So it's going to be 9 times quicker. So we're going to divide by 9. So we do 8.4 divided by 9. And let's write that as a decimal. That will be 0. Sorry, what have I done? 8.4. I didn't mean 8.4. I meant 84. I thought that looked a bit strange. 84 divided by 9. That's better. So 9.3 recurring days. 9.3 recurring days. So that's how long it will take 9 employees. But we need to answer the question. It says, is Davina correct? She said that they'll be able to complete the job in less than 10 days. Well, yes, she is definitely correct. So we can say that 9.3 recurring is less than 10 basically. So although we've said yes and we've given all our workings, I think it's important just to put this last statement just to make it clear that you know that this value is less than 10. Question 12. The box plot shows the time it took Year 7 and Year 11 students to travel to school on one day. Compare the distribution of times it took the Year 7 and Year 11 students to travel to school. Now, with these type of questions, I always look at the marks, and you can see it's worth 2 marks. So that means I'm going to need to give 2 reasons or make 2 points about the distribution of times. So you should give 1 about the average. So with box plots, it would be the median, and 1 about the range. Now, you can either give the interquartile range or just the absolute range. So let's first of all start with the median. I can see the median was greater for Year 11 students. So I'm going to say the median time to travel to school was greater was greater for year 11 students. I don't need to give any figures for this, just saying that it's greater for year 11 students is absolutely fine. Now my second point, I'm going to use the interquartile range. Actually, I think I'm going to use the range. Let's use the range. So let's work out which range was bigger. So this is 5. Each of these small squares is just 1. So this is 3. And the maximum value, well, this is 49 and this is 54. So range, we're going to do 49 minus 3, which is 46. And down here for the year 11 students, it's going to be 54 minus 5, which is 49. So 49 is bigger. So it's also bigger for the year 11 students. So I'm going to say the range in times was greater for year 11 students. Okay, so if you did put 2 points, one about the range and one about the interquartile range, you would only get 1 mark. So you need one about the average and one about the range. And that will give you your 2 marks. Question 13. In a restaurant, there are 7 starters, 9 main courses, and 6 desserts on the menu. Work out the total number of ways of choosing a starter, a main course, and a dessert. So there are 7 starters. For every starter, there are 9 main courses. So the total number of starters and main courses will just be 7 times 9. And then for each of these combinations, well, there are 6 desserts. So we need to multiply that by 6. So we just need to do 7 times 9 times 6. And that gives us 378. So that is the answer. There are 378 different combinations. Question 14. A, B, C, and D are points on the circumference of a circle centered O. Angle ADC is equal to 118 degrees. Angle AOC is equal to X. Work out the value of X. You must show all your working. So for this question, you will need to know your circle theorems. So the first thing I'm going to do is I'm going to work out this angle here, because I can see that we know this angle and there's a special relationship between these 2 angles here. So angle ABC, well, that is going to be equal to 180 minus 118. And the reason I know that is because these angles are opposite angles on a cyclic quadrilateral. So I'm going to write this down. So opposite angles on a cyclic quadrilateral. And what I mean by a cyclic quadrilateral, it's just a quadrilateral inscribed within a circle. So opposite angles on a cyclic quadrilateral sum to 180 degrees. So that's always the case. That's always the case. They always sum to 180 degrees. So this angle is going to be 180 minus 118, which is 62 degrees. So now I've worked out this angle is 62 degrees. Now I can work out my value for X. So X is going to be equal to 62 degrees multiplied by 2. Now, how do I know that it's 62 times 2? And that's because the angle at the center is always double the angle at the circumference. So notice these 2 angles, they both subtend the circumference at the same 2 points. Notice these angles all reach A and C. The angle at the center, so the angle at the center is double the angle at the circumference. Okay, so I know that it's 2 times 62, which is 124 degrees. And that is what we're looking for. We're looking to work out the value of X. So my answer is 124 degrees. Question 15. The cumulative frequency graph gives information about the time in seconds each of 60 people took to complete a puzzle. use the graph to complete, let's underline that, use the graph to complete the frequency table to give information about the time each of the 60 people took to complete the puzzle. Okay, so if we look at our first interval from 0 to 20 seconds, how many people took that long? So we've got our time along the x-axis. So we're going to go up to our upper bound of 20 seconds and read off our graph. And you can see it's this point here. So if we go along to our y-axis, which is that point, and you can see each small square is worth 1. So that corresponds to 6 people. So there were 6 people who took between 0 and 20 seconds. Now to work out between 20 and 40 seconds, let's go along to 40 on our cumulative frequency. And then let's go up to so 40 along the x-axis, 40 seconds. And if we go along, that takes us to this point, which is 16. Now I'm not going to write 16 in there because 16 would be from 0 to 40. So we're only looking from this point to this point. So from 20 to 40. So it's going to be 16 minus 6, which is 10. So it's going to be 10 people. So let's just keep repeating this. So now up to 60 seconds. Up to 60 seconds, we're all the way up here, which is this point. So that's 35, 36, 30. Oh no, I haven't got that quite right. I think I've missed it off. So it should be that point there. So 35, 36, 37, 38. So now it's going to be 38 minus 16, which is 22. And now from 60 to 80. So 80, we're going up to this point. So that's bang on 50. 50 minus 38 is 12. And then up to 100. So 100 is here. So that's 2 above the line. So that is there. So that's 55, 56, 57. 57 minus, where was the last one? 50 is 7. And then the last one, 120 seconds, is on 60. 60 minus 57 is 3. Now, I can do a dummy check now because we know the number for each category. Let's make sure that adds up to 60. So let's just type this into the calculator. 6 plus 10 plus 22 plus 12, not 11, plus 12 plus 7 plus 3. Bang on, we got 60. So I'm quite happy that that is the correct answer. Question 16. Here are 9 cards. Each card has a number on it. Emma takes 2 cards at random. Work out the probability that the sum of the 2 cards is an odd number. So how can we get an odd number when we add up 2 of these cards? Well, let's think about an even plus an even. If we had an even plus an even, well, that's going to give us an even, so that's not going to work. If we had an odd plus an odd, well, that's also going to give us an even number. So that's not going to work. So the only way is if we have an even plus an odd, because that will give us an odd number. So that will work. So I'm going to draw a tree diagram just to represent even and odds. So we're taking a number from the bag, and it can either be even or odd. So what is the probability of it being even? Well, there's 1, 2, 3, 4 evens. There's 4 evens out of 8. Not 8, there's 9. There's 9 numbers. So it's 4 out of 9 for an even. And odd, well, that will be 5 out of 9. So now we're going to pick another card because we're picking 2 cards. So the second card, well, that is also, it can either be even or odd. So for each one, it's going to be even or odd. So what we don't really need to calculate even and then even because we know that's not part of our calculation. Like that's not going to be relevant to us at all. So even odd, what is the probability of the second card being odd? Well, there are 5 odds out of 8. It's not 9, remember, we've taken a card out already. So we've taken an even card. So there's only 8 cards left. So there's still 5 odds, but now there's only 8 cards in total. Now, we said even then odd would work, but also odd then even. That would also work. That's just this, but switched around. So what would the probability be of taking an even after we've taken an odd? Well, there's still going to be 4 evens because we haven't taken an even yet. But now there's only going to be 8 in total. So what is the probability going to be if we go up this branch? Well, that will be 4 over 9 times 5 over 8, which will be 20 over 72. Or we could go in this direction. Well, that's going to be 5 over 9 times 4 over 8. That's exactly the same. So that is 20 over 72. So we can take either one of these roots and that will give us an odd total. So we can just do 20 over 72 plus 20 over 72. Well, that gives us 40 over 72. So that's going to be my answer. That is the probability of getting a sum, getting an odd number from the sum of the two cards, 40 over 72. You don't need to simplify this. This is absolutely fine. You will get 4 marks for this because it doesn't say simplify your answer. But if you did simplify it, I think we can divide both numbers by 8. So that will be 5 over 9. So either one of these answers or anything equivalent would give you the 3 marks. Question 17, part A, using this iterative formula where our first input is 5, find the values of x1, x2 and x3. So we've been given an iterative formula here and we've been given the first input. So I'm going to substitute this value into our formula. So our first iteration, x sub 1, well, that is going to be equal to the square root of 6 times our first input, which is 5. And then take away 1. So let's put that into our calculator. It's going to be the square root of 6 times 5 minus 1, which gives us root 29. But if we convert that to a decimal, we get our first iteration. So I'm going to put that over here. 5.385164807. So that is our first iteration. Our second iteration, well, that is going to be 6 times the next value. So it's basically the answer from our previous iteration is going to be the input for our next iteration. So I'm just going to write in here answer instead of writing all of this business and then take away 1. So on my calculator, I'm going to do the square root of 6 times previous answer minus 1. And that gives me 5.59562293. So that's x sub 2. Now x sub 3, we're going to do exactly the same thing. So 6 times previous answer minus 1. So square root of 6 times previous answer minus 1 is equal to 5.70734. So we've got our 3 values for x1, x2 and x3. And if you found x4, you didn't need to do this whole procedure again. You could just keep pressing equals and you can see, you know, I'm probably up to about x sub 30 by now, just by pressing x, and eventually it will tail off and this will be the solution to the equation. And actually that's where I'm leading on to the next part. So part B says explain the relationship between the values of x1, 2 and 3 and the equation of x squared minus 6x plus 1 is equal to 0. So what we need to do is we need to rearrange this equation to get x on its own. So we've got x squared minus 6x plus 1 is equal to 0. So first of all, let's get x squared on its own. So to do that, I need to add 6x to both sides and subtract 1 from both sides. So we'll be left with x squared is equal to 6x minus 1. And now to get x on its own, well, I need to take the square root of both sides. So I'm going to be left with x is equal to the square root of 6x minus 1. And now notice, if we look at this equation, well, this is exactly the same as our iterative formula. The only difference is with these subscripts. But if you take these subscripts away, it is the same equation. So what are these values for x1, x2 and x3? Well, these are just solutions or estimates of the solution to this equation over here. So we can say that x1, x2 and x3 are estimates because we know they're not the exact solution. We got the exact solution. The exact solution is 5.828, etc. So these are estimates to the solution of the equation. I'm just going to write down the equation. X squared minus 6x plus 1 is equal to 0. So they're estimates to this equation because when we rearrange this equation, we got this iterative formula over here. Question 18. The graph below shows the speed of a car in meters per second, t seconds after it starts moving. So you can see that, 4 seconds after it starts moving, the speed of the car is sort of this value here. So part A, we need to calculate an estimate for the gradient of the graph when t is equal to 7. You must show how you get your answer. So when t is equal to 7, where are we? T is equal to 7 is here. So if we go up to our graph, that is this point here. Now, we're not going to read off our graph because that would be the speed. We're not looking for the speed. We're looking at the gradient of the line. Okay, calculate an estimate for the gradient of the graph. So what we need to do is we need to draw a tangent line at this point. So I'm going to get my line tool out. So a tangent line is a line that just touches the graph at exactly one point, and that point is here. So I'm going to probably have a few goes at this. So that's not quite right. I need to bring it up this way a bit. I think I need to bring it this way a bit. And then, so I'm going to have a few attempts. Almost there. Just going to go a bit more. And again, you can obviously, you've got your rubber, so you need to make sure you use your ruler. I think that is probably going to be as best as I can get. So obviously the direction is really important, and it just needs to touch that point at only that point. Everything else, there should be a gap. So that is going to be my tangent line. So now I've drawn my tangent, I need to calculate the gradient of that line. So let's pick 2 points on the line, and I like to pick points that are furthest apart. So I think I'm going to pick that point there. And if we go right to the x-axis, I'm going to pick that point. If you pick 2 points that are as far apart as possible, that will give you more margin for error. So the gradient of the line, so the gradient, we know to calculate gradient, it's change in y over change in x. So the change in y, this value here, well, if that's 17.5, each of these is 0.5, so that's there. So that's going to be 18.5. It's going to be 18.5 minus 0 because the y value here is just 0. And then our change in x, well, we're going from 10. So it's going to be 10 minus this point. So this is 3. So now it looks like each small square is 0.2. So that's going to be 3, 3.2, 3.4. 3.4. So let's put this into our calculator. In the numerator, well, we've just got 18.5. And then in our denominator, we've got 10 minus 3.4. And we get 2.803, where the 0 and the 3 are recurring. So that's going to be my answer. The gradient of the line is 2.803 with the 0 and the 3 recurring. And this isn't going to be the exact answer. So in the mark scheme, there will be a range that they will allow. Now, I don't know if this is what they will allow. I've just looked at the answers from Maths Genie, and they've put 2.7 recurring. So it probably is okay, but I wouldn't be able to tell you if this would give you the 3 marks. But this is the methodology. So I would at least get 2 marks, even if I didn't get, even if my line wasn't perfectly accurate. So moving on to part B, it says describe what the gradient in part A represents. So this figure we got of 2.803, what does that represent? And don't say the slope, because you're not going to get a mark if you just say the slope of the line. Okay, you need to actually say what it represents in real life terms. So to get this value, we did the change in y over the change in x. So what does this represent? The change in y, well, that was the speed, so the change in speed. So let's write that down. The change in speed. And then we divided that by the change in x. Well, that was the change in time. The change in time. So we essentially did the change in speed over the change in time. And this, well, that is just the definition of the acceleration. So acceleration. So what we calculated, this figure, well, that is the acceleration of the car. And you probably don't need to say of the car, but you definitely need to mention acceleration to get the mark. Question 19. Show that this expression can be written in this form where a and b are integers. So what we're going to have to do, at the moment we've got different denominators. We can't add these three terms together because they've got different denominators. We're going to have the same denominator. So what is the lowest common multiple of x minus 3, x plus 3, and 1? Well, that's just going to be x minus 3 times x plus 3. So our denominator is going to be x minus 3 times x plus 3. That's going to be our denominator for each fraction. So if we think about the first term, to go from x minus 3 to this, what do we need to multiply the numerator by? Well, we need to multiply it by x plus 3. So it's going to be 2x plus x plus 3. And you can see that these two terms will cancel and we'll just be left with that. So these two fractions are essentially the same. And then the second fraction, well, our denominator is also going to be x minus 3 times x plus 3. So now to go from this denominator to this denominator, we multiplied by x minus 3. So we need to do the same to the numerator. So we're going to have 3x minus 1 times x minus 3. And then plus 1, well, 1 we can just write, well, we need the same denominator, x minus 3 times x plus 3. So our numerator is also going to be x minus 3, x plus 3. So now notice we have the same denominator. We can add all of these fractions together. So I think what I'm going to do is as I go, I'm going to expand the brackets as I go. So for this first fraction, we're going to have 2x squared. 2x times x is 2x squared. Plus 2x times 3 is 6x. And then we're going to subtract. And I'm actually going to put brackets in here because a lot of people make this mistake, is that they expand the brackets and then they forget about this negative sign. So I'm going to put brackets in first. And then I'm going to expand my brackets. So 3x times x is 3x squared. 3x times negative 3, well, that is negative 9x. Negative 9x. Negative 1 times x is negative x. And then negative 1 times negative 3 is positive 3. So remember, we're subtracting this whole expression. And then we're adding on. And I don't need to put brackets in, but I'm just going to do it anyway, just to show that it all relates to this fraction over here. So we're going to have x times x, which is x squared. X times 3 is plus 3x. Negative 3 times x is negative 3x. And I can see that these will cancel, but I'm just doing every step. And then negative 9. Negative 3 times 3 is negative 9. Okay, and then we're going to put all of that over our denominator, which is x minus 3 times x plus 3. And actually what I'm going to do is I can see that if I just expand that, I will be left with this. So let's just expand these brackets. We're going to have x squared minus 9. Okay, now we need to clean up the numerator. So we've got 2x squared plus 6x. And then we're subtracting 3x squared. This is where people make the mistake. We're subtracting negative 9x, so that's plus 9x. We're subtracting negative x, so that's plus x. We're subtracting 3, so that's minus 3. And then we're adding on x squared. And now I think I'm just going to simplify this. 3x minus 3x is just 0. So then we've just got x squared minus 9. And then again, all of that is over x squared minus 9. And now I think all we need to do is simplify our like terms. So let's color coordinate this. We've got 2x squared minus 3x squared. That's going to be negative x squared. and then plus x squared, well, that's just going to be 0. Negative x squared plus 3x squared is just 0. So all three of these terms just cancel. Now, if we focus on the x terms, we've got positive 6x plus 9x, that's 15x, plus another x, that's 16x, and I think that's all of them. So we've got 16x. And now if we think about the constant terms, we've got negative 3 minus 9, that's negative 12. And then in our denominator, we've got x squared minus 9. And I don't think we can simplify that anymore. And notice if we compare that to the form that they want, well, it is that form. So A, we don't need to write this, but just to make it clear, A is the coefficient on the x term, which is 16. B is the constant term, which is negative 12. And we've got x squared minus 9 in the denominator. So we are done. Question 20. Here is a shape formed from two triangles, ABC and CDE. And we're told ACD and BCE are straight lines. And we're told a bunch of dimensions here on our diagram and also the angle BAC. We need to work out the length of DE. So DE is this length here. Give your answer correct to 3 significant figures. So there is a lot going on in this question. It's worth 5 marks. So we can see that these two triangles, I can see straight away that these are opposite angles. So these angles are identical. Now we've got a bit more information over here because we've been given this angle. So if we can work out what this angle is, we can that's obviously going to be the same as this angle. And then from that, we can then work out this length. So I think I'm going to try and work out what this angle is. Now we can use the sine rule to calculate this angle. So let's just do that in a different color actually to make it clear. So we can calculate that angle using the sine rule. So let's just call that x. So we can say that the sine of x over 12, well, that is going to be equal to the sine of 78 degrees over 15. So to calculate what x is, well, x is going to be equal to, well, actually, first of all, what I'll do is I'll get sine of x on its own. So if we multiply everything by 12, we get the sine of x is equal to 12 times the sine of 78, all of that over 15. And then to get x on its own, we're going to take the inverse sine. So it's going to be sine to the negative 1 times 12 times the sine of 78, all of that over 15. Okay, so let's put all of this into the calculator. So we're going to do shift sine, and then it already opens up our brackets. So I'm going to put the fraction in, and then it's going to be 12 times the sine of 78, close brackets. Then in our denominator, we've got 15, and let's go along and close our brackets. And we get 51.49. I'll just write down the whole thing. 17102 degrees. So we found out what x is. Now to calculate what this angle is, so this is angle BCA. So angle BCA, well, it's just going to be 180 minus 78 minus 51. I'm not going to write the whole thing, so I'm just going to round to 2 decimal places, 49. So we're going to do 180 minus 78 minus previous answer, because that was already saved, and we get 50.51 degrees. So that is what this angle is here, which is going to be the same as this angle. So I'm going to write in here 50.51 degrees because these are opposite angles. So now we can calculate DE using the cosine rule. So I'm just going to write down what the cosine rule is. So we can say that a squared is equal to b squared plus c squared minus 2bc times the cos of a. So if we think about the values that we've been given, so a is going to be DE. So we can say DE squared is equal to b squared. Let's just say it doesn't matter which one's b and which one's c. So 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of this times the cosine of 50.51. Okay, there's a lot going in here. So let's put all of this into the calculator. So now it's already saved this 50. So actually, to be a bit more precise, I'm going to use the answer in my calculation. So we've got 10 squared plus 16 squared minus 2 times 10 times 16 times the cosine of previous answer, because that was saved, and press equals, and we get 152.49. And remember, that is DE squared, so we need to be careful. That is DE squared, so DE is going to be the square root of that, square root of 152.9. So let's just square root our answer, and we get 12.34 or 35, if we round up, 35, and that is going to be in centimetres. And that looks about right. Okay, so if we've got 10, 16, 12.35 looks about right. I don't think I've done anything terribly wrong. But we just need to think about what it says here. It says give your answer to 3 significant figures. So it looks like I'm going to round. Now I need to be careful. I'm not going to round this up, because looking at my value from my calculator, it's going to round down. So actually, maybe I should change this to 348 centimetres. And now if I round this to 3 significant figures, it's going to be 12.3 centimetres. Question 21. Solve algebraically the simultaneous equations. So it looks like we've got one quadratic equation and one linear equation. So whenever you have a situation like this, always substitute the linear equation into the quadratic. So we're going to need to rearrange this linear equation. So we've got 3x minus 2y is equal to 8. Now you can either make x the subject or y the subject. It doesn't really matter. But for this equation, just looking at it, I think I'm going to make y the subject. And that's because to get y on its own, I'm going to need to divide by 2. And I can see that 8 divides by 2 quite nicely. So let's first of all get the y's on the right hand side. So we're going to be left with 3x is equal to 2y plus 8. And now if we subtract 8 from both sides, we'll be left with 3x minus 8 is equal to 2y. And now we can divide everything by 2. We get 3 over 2x minus 4 is equal to y. So now we've got y on its own. I can substitute this expression for y into my quadratic equation. So what have we got? We've got x squared. So x squared plus 2 times y squared. Well, we said instead of writing y, we can write all of this. So it's going to be 3 over 2x minus 4, and then all of that squared, and that is equal to 10. So let's work out what this is first of all. So we've got x squared plus 2 times all of this. So remember to do this first, because squaring comes before multiplying. So 3 over 2x times, actually what I'm going to do is I'm just going to expand it all. I'm just going to write it in full. So we've got 3 over 2x minus 4 times 3 over 2x minus 4, and that equals 10. You don't need to do this extra step, but I'm just trying to show you every step that I'm doing. So we've got x squared plus 2 times, so 3 over 2 times 3 over 2, well that is 9 over 4, so it's going to be 9 over 4x squared. And then we've got 3 over 2x times negative 4, that's negative, so 4 divided by 2 is 2, 2 times 3 is 6, so that's negative 6x. And then this here, the inside terms, well that's going to be exactly the same, that's going to be negative 6x. And then our outside terms, negative 4 times negative 4 is plus 16. And that equals 10. So now we just need to expand out this 2. So remember, 2 is being multiplied by everything inside the brackets. So we've got x squared plus 2 times 9 over 4. Well, that's 9 over 2. So 9 over 2 x squared. Now, inside the brackets, we can just tidy this up. Negative 6x minus another 6x. That's negative 12x. And then when we multiply by 2, that's going to be negative 24x. And then we've got 2 times 16, which is plus 32. And then all of that is equal to 10. Okay, I think the next thing I'm going to do is I don't like this fraction here. So I'm just going to multiply everything by 2 just to get rid of this fraction. So we're going to have 2x squared plus 9x squared minus 48x plus 64, and that is equal to 20 because I've just multiplied everything by 2. And now I think we can simplify this. So we've got 2x squared plus 9x squared. That will give me 11x squared. Negative 48x plus, oh no, I thought that was an x there, but it's just 64. So we've got minus 48x. And then we want to get 0 on its own to solve a quadratic. So I'm going to subtract 20 from both sides. So we'll be left with plus 44, and that equals 0. So I think we can't simplify this anymore. So now we've got a quadratic equation to solve. And to solve this, I'm going to use the quadratic formula. So our solutions, x is going to be equal to negative b. Well, b is negative 48. So it's going to be positive 48. Plus or minus the square root. Let's make this quite big. So b squared. So it's going to be negative 48 squared minus 4 times a, well, a is 11, times c, which is 44. So b squared minus 4ac, and then all of that is over 2 times a, so 2 times 11. Okay, now let's put all of this into the calculator. So in our numerator, we've got 48. Let's do plus first. I will change this to a minus after, but let's do plus first. So we've got, well, negative 48 squared. That's just going to be the same as 48 squared, so I don't need to worry about the negative there. And then minus 4 times 11 times 44. And then in our denominator, we have got 2 times 11. So we press equals and we get this business here, but let's just convert that to a decimal. We get 3.054. I'm just going to round that to 3 decimal places. Or we need to remember there's 2 solutions. So that's one of the solutions. The other solution, I'm just going to replace the plus with a minus, press equals, and then we get our other solution, which is 1.310 if we round that to 3 decimal places. And now I have my values for x. I can substitute these into my linear equation. And what I'm going to do is I'm going to put it into this linear equation down here, because it will just be a lot easier to work out. So what do we have? We've got 3 over 2 times 3.054, and then we're going to subtract 4. So what does that give us? We've got, so this is essentially 1.5. So I'm just going to do 1.5 times 3.054 minus 4, and we get 0.581. And now I'm going to do exactly the same for this solution. So we're going to do 3 over 2 times 1.310 minus 4. So I'm just actually going to take away the 3.054 and just replace that with 1.310. Everything else is the same. Press equals and we get negative 2.035. So we've got our solutions for y. So now we just need to make sure we match these up. So we can say x is equal to 3.054, and y is equal to this one. This was the y that corresponded with this x value, so 0.581, or x is equal to 1.310 and y is equal to negative 2.035. So these are our two solutions. Question 22. A solid cube has a length of 4.8 centimeters, correct to one decimal place. The cube has a mass of 220 grams, and that is being rounded to two significant figures. Work out the upper bound for the density of the cube. Give your answer in grams per centimeter cube, correct to two decimal places. So let's just remind ourselves how we calculate density. So density, the formula is mass over volume. And notice we're working out the upper bound for density. So the upper bound for density, we need to make the density as big as possible. So if we've got a fraction, we're going to try and make the numerator as big as possible. So that's going to be the upper bound for the mass. But we want to make the volume as small as possible because we want a big number divided by a small number. So that will be the lower bound for the volume. So what would the upper bound for the mass be? Well, we know the mass is 220 grams. So let's write that down over here, 220 grams. So let's work out what the lower bound and the upper bound would be for the mass. So it's been rounded to two significant figures. So the lower bound would be 215 grams, because if we round this to two significant figures, notice the 5 would mean this would be rounded up to 220 grams. And then the upper bound will just be the same but in the opposite direction, so that would be 225 grams. So this is the figure we need. So it's going to be 225 grams divided by the lower bound for the volume. So we're not actually told what the volume is, but we're told the length. So the length is 4.8 centimeters. So again, let's work out the lower bound and the upper bound. So it's been rounded to one decimal place. So it's going to be 4.75 centimeters for the lower bound and 4.85 centimeters for the upper bound. But this time we're interested in the lower bound, so we're going to use this figure here. But I'm not going to put this in the denominator because this is just the length. Remember, we need the volume. So the volume, well, that is going to be 4.75 times 4.75 times 4.75, or just 4.75 cubed. So 4.75 cubed. And I'm going to write all of this down. 107.171.875. So this is my volume. So let's write it down, 107.171.875, and that is going to be in centimeters cubed. And I need to extend my fraction here. So let's just put all of this into the calculator, and this, you can see this number's saved already. So we just need to do 225 divided by previous answer, and if we round that to a decimal, we get 2.099. And just look, and let's just write our unit. So our units is grams per centimeter cubed. You can see it, grams divided by centimeter cubed, which is what they want. But they do want it rounded to two decimal places. So it's going to be 2.10. So 2.10, and you can see our units are already here, grams per centimeter cubed. Question 23, and this is the last question in the paper. The diagram shows quadrilateral OABC. ADB and ODC are straight lines, so that's just these two lines that intersect. And we're given a bunch of vectors, and we need to, using a vector method, find the ratio AD to DB. So AD is this vector here. So we need to work out the ratio of AD to DB, so that vector there. So let's first of all focus on AD. So if I write down vector AD, how can we get from A to D? Well, we could go from A to O and then O to D. So AO plus vector OD. Now we know what vector AO is. AO is just the opposite direction of vector OA, so that's going to be negative 5a. Now vector OD, we don't know anything about vector OD, but we do know something about vector OC, okay, because we can go all around the outside. So we know that vector OD, because this is a straight line, it's some fraction of OC. So I don't know what fraction it is. Let's just use the letter x. So it's going to be some fraction x times vector OC, and vector OC is going to be 5a plus 2a plus 3b. So let's just simplify this a bit. We've got negative 5a plus some fraction of vector OC, which is 5a plus 7a is 5a plus 2a is 7a, and then plus 3b. So what I'm going to do is I'm just going to expand this bracket here. So it's going to be some fraction of 7a plus some fraction of 3b. So it's going to be negative 5a plus 7 times xa plus 3 times xb. So this is our vector AD. Now we can also, because at the moment we don't know what this value for x is, we're going to have to find another way of getting from A to D. So instead of going the way we just did, well, we can say that AD is some fraction of vector OB. Okay, so similar to before, we said that OD was some fraction of OC. We can do exactly the same here. AD is some fraction of AB. And again, we don't know what that fraction is. It could be a third, it could be a quarter. So I'm just going to use y to represent that fraction. So we can say that vector AD, well, that is equal to some fraction of vector AB. Because again, this is a straight line. So it's some fraction of vector AB. Now we can work out what vector AB is. So it's going to be y times AB is, to go from A to B, we can go to A to O. So that's going to be negative 5a. And then we can go from O to B, so that's plus 6b. And again, we can expand the brackets. So we've got negative 5 times yb plus 6 times, sorry, not yb, ya plus 6 times yb. So notice now we've got two representations of AD. So let me just make that clear. AD is equal to all of this business, but also we worked out that AD is equal to all of this business as well. So what we can do is now set these expressions equal to one another. So we can say that negative 5a plus 7xa plus 3xb is equal to negative 5ya plus 6yb. And now if we compare the two, let's compare the let's compare the b terms first, because we've got less of those. So if we look at the b terms, we've got 3xb, and that is equal to, in terms of the b terms, 6yb. So we can now say that because we've got b in both of them, we can say that, let's do it over here, we can say that 3x must be equal to 6y. Okay, because they're both our b vectors. So they're both our b vectors and they equal each other. So they must be the same. So 3x must equal 6y. Therefore, to work out what x is, well, we can just divide both sides by 3. So we get x is equal to 2y. So now we've looked at the b terms, let's look at the a terms. So I'm just going to highlight the a terms on each side of our equation. So we can just equate these. So because they're all a terms, we know that the coefficients must be the same. So we can say that negative 5 plus 7x must be equal to negative 5y. And now because we know the value for x, or we've got an expression for x, so we know that x is equal to 2y, we can just substitute 2y into this value for x here. So we can say that negative 5 plus 7 times 2y must be equal to negative 5y. So we get negative 5 plus 14y is equal to negative 5y. And then if we get all of the y's on one side, so let's put all of the y's on the left-hand side, 14y plus 5y, well, that will be 19y. And on the right-hand side, if we add 5 to both sides, we get 5 on the right. So now we've got 19y is equal to 5. Therefore, y must be equal to 5 over 19. And that is what we want. We want this value for y because we need to work out the ratio AD to DB. So if y, which is the same as AD, is equal to 5 over 19, that means that DB must be equal to 14 over 19, because we know that this is just broken down into two parts. So if we're thinking about the ratio AD, so AD to DB, well, there's 19 parts, 5 of them are AD and 14 of them are DB. So the ratio is going to be 5 to 14. So that would be the final answer. So we have now come to the end of this walkthrough. So I really hope you found this video useful. And I will also be doing a paper 3 walkthrough. Hopefully it will be a couple of days after the paper 2 exam has been completed. So I just really want to wish you the best of luck for your exams, and hopefully I'll see you for the next video. Take care.